Hello and good day, Algebra. This is Mr. Schultz coming to you with the Middle School Math Entrance Exam Review Packet. Your entrance exam is going to be the first week of school. I heard all the cool teachers give a test the first week of school, so obviously I need to partake in that. And this is going to be your go-to resource in preparation for this exam. So let's talk a little bit about what it's going to contain. The purpose is to shake off the rust of summer and show me that you remember the most important concepts from pre-algebra. We've talked before about how math is kind of like swimming lessons. You know, you start swimming lessons in level 1 for a reason, and you are only allowed to progress to each new level once you've shown that you've mastered where you're currently at. Well, pre-algebra is named pre-algebra because it's a precursor to algebra. And the things we talked about last year, being familiar with them is going to be very, very important for your success in this class this year. This review packet is optional. I'm not going to grade it. I'm not going to collect it. You do not need to turn it in. This is only for your personal preparation. The entrance exam itself will be graded on the number of objectives passed. There will be 20 objectives on the exam, so 20 total points. Each objective will have 3 questions, and in order to pass it, you need to get 2 of those 3 questions correct. Any objectives that you do not pass will need to be practiced and retaken before the end of September. You may use a calculator. You may also use a help sheet. Those of you that had, whether you had me or Mrs. Gambino, you know that help sheet can have definitions, formulas, verbal reminders. The only thing it can't have is actual worked out examples of questions. For review, this video is obviously a good thing to watch. You can also search for concepts on Khan Academy, the Google, your binders from last year, or if you want to watch the full lesson, you can find it by searching for it by objective number on my YouTube channel. The web address is right here, and don't forget to like and subscribe, of course. And then answers to this packet will be posted on the bulletin board in Blackbaud on Monday, August 29th. My inbox is always open, so feel free to send over any questions, comments, concerns, complaints, compliments, congratulations, or criticisms at any time. So I'm really going to just go over each objective briefly, not every single question, but just kind of, what you should be thinking about and remembering as you do this review yourself. So for greatest common factor, there's 2 methods that we talked about. I'll show the first method on number 1 and the second method on number 2. And the first method is simply listing the factors of each number. So for 6, the factors are 1 and 6, and 2 and 3. For 16, the factors are 1 and 16, 2 and 8, and 4 and 4. So factors, done. Next, I want to look for the common factors. What factors show up in both lists? Well, there's a 1 in both lists and a 2 in both lists. So common factors, done. And then my actual answer is going to be the greatest of those common factors. So 2 is greater than 1, and so 2 is the greatest common factor, the largest factor that both numbers share or have in common. The second method is the table method. So we're going to want to make a table like this, okay? 18 and 45 go across the top. And what I'm looking for here is, what can I divide both 18 and 45 by? I'm not necessarily looking for the greatest common factor yet here. I'm just looking for a common factor, So I'm going to try 2. Well, I can divide 18 by 2, but not 45, so that's not going to work. I can divide both by 3. So I'm going to put 3 here. I'll do that in a different color. So my 3 goes here. And then I'm going to divide 18 by 3 and 45 by 3. And the next row of my table is going to be the quotient of each of those. So 18 divided by 3 is 6. 45 divided by 3 is 15. Now I look at 6 and 15, and I kind of do the same thing. What can I divide both of those numbers by, or what's a common factor for each of them? Again, here it happens to be 3. So again, I'm going to divide 6 by 3 and divide 16 by 3. In the next row of my table here, that gives me 2. And 15 divided by 3 is 5. Now, 2 and 5 don't share any common factors, so I know that I'm done. And my final answer is going to be the product of my numbers in red here, the product of the factors that I took out. 3 times 3 equals 9. So the GCF of 18 and 45 is 9. So doesn't matter which method you use, listing or table, both of them work just fine, but there they are for you. Next objective, we've got compare and ordering rational numbers. Rational numbers include integers, decimals, and fractions. For integers, I just recommend thinking about them like a number line. You know, if you were to plot each of those numbers on a number line, how they look from least to greatest. Decimals, we kind of talked about that stacking method. The stacking method is aligning these decimals vertically. So 2.212 or 0.212, 0.3, 0.25, and 0.257. And then the thing with decimals is that you can add zeros to the end of a decimal and not change its value. So my longest decimal goes out to 3 places here. And so I'm going to add zeros so that they all go out to 3 places. And what this allows me to do now is kind of just focus on the numbers after the decimal point and think, what's the order from least to greatest? You know, 212 is the least. And then next would be 250. And then next would be 257. And finally, 300 would be the greatest. So my order, 0.212, followed by 0.25, followed by 0.257, followed by 0.3. Okay, stacking method. Then for fractions, common denominators is probably a method you've used before. You can also just kind of think about the values in terms of like 0 or half or 1 whole. Like in number 5 here, I know that 2 halves is 1 whole. It's something divided by itself. And I know that the other 2 fractions are both proper. They're both less than 1. So I know that 2 halves has to be my greatest one. And then looking at 3/7 and 8/9, you know, think about it like a test score. You know, 3 out of 7, yeeks. 8 out of 9, it's pretty good, right? So turns out these fractions are already in least to greatest order for you. 3/7 is the lowest. 8/9 would be in the middle, and then 2 halves being a whole fraction equal to 1 whole, that would be the greatest. And of course, you could use common denominators for that as well, but lots of ways to go about that one. Next one, adding and subtracting rational numbers. Rational numbers, again, integers, decimals, fractions. For the integer section here, the one I want to bring your attention to, -16 minus -4. Remember that subtracting a negative is just another way to write addition. Okay, the other way to write addition. So you can rewrite this to be -16 plus 4. Right? That first number has nothing to do with the operation. It's just where you start on the number line. And then what's in between the numbers dictates which direction on the number line that you go. So we're starting at -16. We're adding 4, which is going to the right. This would be -12. If in your head you were thinking -20, that's actually left of -16, right? You want to go to the right because we are adding there. That minus negative means that we're adding. For decimals, align them vertically. Make sure you got your decimal point lined up correctly. And then for fractions, of course, common denominators, right? Adding and subtracting fractions. For 2/5 plus 1/3, I'm going to want to change each of these to be out of 15. So I'm going to multiply by 3 and by 3 to get 6/15. Multiply by 5 to get 5/15. And then when I do my actual addition, that 15 doesn't change, right? My denominator has to be the same, and it stays the same. My numerators are what get added, and I have 11/15 as an answer. You know, the denominator of a fraction is kind of like an object. It's a thing that you have. You know, you have 6 of something, you get 5 more of something. Total, you have 11 of that something, right? It has to be the same, and it stays the same. 15th is like a thing. Okay. Moving on. Next objective: multiplying and dividing integers and fractions. For multiplying and dividing with negatives, you know, one thing that might be helpful to put on a help sheet is this kind of table if your signs of the numbers are the same, either both positive or both negative, in both cases, your answer is going to have a positive sign. It will be a positive value. If one is positive and the other negative, doesn't matter the order, in this case, your answer is going to be a negative value. Okay, so looking at that first one, negative 3/8 times 9/10. Once I determine that my answer is going to be negative, because I've got a negative fraction times a positive one, I can kind of just ignore it, right? I know my answer is going to be negative because of that sign there. And so let me now do my multiplication without worrying about that sign. So it doesn't have the potential to throw me off. For multiplying fractions, you multiply straight across. So 3 times 9, 27 will be my numerator. 8 times 10, 80 will be my denominator. So negative 27/80 would be my answer. If I could simplify that, then I would. However, 27 and 80 don't share any common factors, so I'm good to go. If one of your numbers has an improper fraction, like in number 3, convert that, or sorry, if it has a mixed number, convert that to an improper fraction first. For division, you got a couple different options here. Again, looking at the, well, I'll do number 5 because it's got that mixed number there. So looking at my two signs, I've got two negatives here. So I know that they're going to cancel out, and my answer is going to end up being positive. So once I've determined that, I can just kind of ignore them and focus instead on what I have here. 8/5 divided by 1 2/7. Now I'm going to want to convert that mixed number to an improper fraction, which kind of the shortcut for that is multiplying your denominator by the whole and then adding your numerator. So 7 times 1 is 7, plus 2 equals 9. And so this is 8/5 divided by 9/7. Okay. Now you've got two methods that you can actually divide this, neither of which actually includes division, which is kind of funny. Okay. But the first method would involve flipping that second fraction and multiplying. I'll kind of do that over here. So instead of 8/5 divided by 9/7, we would do 8/5 times, flip that second fraction, 7/9. And now that we're multiplying fractions, we go straight across. 8 times 7 is 56. 5 times 9 is 45. Okay? It's an improper fraction, which is okay. We actually use improper fractions more than mixed numbers in pre-algebra, algebra, and going forward. So it's okay to leave your answer as an improper fraction as long as it's in simplest form, which this one happens to be. Okay? My other option is to leave it written the way it is, 8/5 divided by 9/7, and use cross products to multiply instead. And notice that either way that I do this, I end up multiplying the same numbers together, right? Either way, I end up multiplying 8 and 7 to get 56, and I end up multiplying 5 and 9 to get 45. So it's really just, one method isn't better than the other. It's just how your brain thinks. And both are perfectly acceptable methods to use. So 56/45 would be our answer for that one. Onward we go. PO18, solving two-step equations. Two-step equations mean that you've got a variable with some, usually a coefficient, some sort of multiplication or division, and then a constant, addition or subtraction. Okay, so you've got to deal with the addition or subtraction first, then the multiplication and division second. And opposite operations would be the method that I prefer that you use for this. Since we're adding 8, it says 4n plus 8 equals 36. Since we're adding 8 and we want to undo that, we're going to be subtracting 8, right? Because subtraction is the opposite of addition. So 8 minus 8 causes those to cancel out. We have 4n, and 36 minus 8 equals 28. Well, now we got 4 times n, and the opposite of multiplying is dividing, right? So we're going to divide both sides by 4. That's going to cause these 4s to cancel out, and we're left with n equals 7. And these equations are super easy to check because you take that 7, plug it back in to our original equation, 4 times no longer n, but now 7, plus 8, does that equal 36? Yes, it does. 28 plus 8. So you're good to go. Okay. If you've got some division going on, like in number 4 there, n divided by 5 minus 5 equals 12, I'm still going to start with that addition or subtraction. And this time, because I'm subtracting 5 in my original equation, I'm going to add 5 to undo it. That leaves me with n divided by 5 equals 17. And remember that a fraction bar really just means divided by. It means division. So if it helps you to write it out horizontally, n divided by 5 equals 17, those two expressions, those two equations mean the exact same thing. Either way, the opposite of division is multiplication. So I'm going to multiply both sides by 5. Some folks like to write it out like this so it fits better below there. But either way, the 5's cancel out, and 17 times 5 is 85. 5's cancel out, 17 times 5 is 85. Checking this, does 85 divided by 5, which is 17, minus 5, 17 minus 5 equals 12. Checks out. Okay? So for those two-step equations, opposite operations, start with any addition or subtraction, and then move to your multiplication or division. Next up, we have a percentage of a whole number. So there's a formula that we can use for any percent type equation, and that formula is part over whole equals percent over 100, because the word percent literally means out of 100. So when the question is, what is 60% of 30, remember that whatever follows the of is our whole. This is obviously our percent, which means we're solving for the part. So P over 30, part over whole, equals 60 over 100. How would you solve any proportion? You've got a number of different methods. You could use scale factor. Cross products is probably easiest for this one. So we're going to take 30 times 60, which is 1800, and then divide by the 100. And so 18 is 60% of 30. Someone told me about a TikTok video that showed them a little shortcut here, which certainly works. 6 times 3 also equals 18. Ta-da! Okay, so why would you do this whole cross products, equation formula way if you can just do 6 times 3 is 18? Well, because not everything always works out so evenly. 65% of 50, that little TikTok trick, isn't going to exactly work here, right? So this is where you might want to set up, here's my part, here's my percent, here's my whole. Part over whole equals percent over 100. And this one actually you wouldn't necessarily need to do cross products, because this has got a nice little scale factor, which is another way to solve a proportion. 100 divided by 2 equals 50. So 65 divided by 2 will give us our part. Like, hey, this is going to be a decimal. Well, that's okay. You're in algebra now. Decimals happen, so just roll with it. All right. Next one, we've got find a part, whole, or percentage using an equation or proportion. Here's where that cross products method is really going to be helpful, because what you're solving for is switching every single time, right? Here you've got what number? You're solving for the part, your percent, your whole. Here you're solving for the percentage. Here's your part, here's your whole. Here you're solving for the whole. Here's your part, here's a percentage, right? And just as a reminder, how you identify what the whole is, really the best way is to look for that word of. Okay, look for that word of. So for all three of these, you're using the part over whole equals percent over 100 equation, proportion. Plug the pieces that you have. Use cross products to find the piece that you don't have. But let's focus on a word problem down here. I don't want to be accused of leaving all the hard things for you to do. Number 4 here. You use your favorite taxi company for Faffelton Pfefferpfaff's fares to get from your house to the airport. You leave a 20% tip on a $56 fare. To the nearest cent, what was the amount of the tip? So the difficulty with word problems is that, it's not always laid out so easily, right? It's not as easy to identify what the part, the percent, or the whole is, okay? But here's kind of the important statement. You leave a 20% tip on a $56 fare. Well, obviously 20 is going to be our percent. And so that leaves us to decide, is the 56 the whole or is it the part? The whole or the part? Well, if that's how much that you paid and a tip is a percentage of that price, well, this is going to be our whole, which means what we're selling for, the tip, is our part. So using our proportion, part over whole equals percent over 100, this would be a great opportunity for cross products. Right? 56 times 20 is 1,120. Divide that by 100, and we left an $11.20 tip on that $56 fare. Okay? So word problems need to identify that part, whole, percent, set it up, and cross products to solve. 30, unit rate for a given ratio. The thing about unit rates is that they always have a denominator of 1, right? Unit rates are always out of 1. So if the first rate given here, number 1, is 180 minutes in 3 hours, 180 minutes in 3 hours, the unit rate is going to tell us how many minutes in 1 hour. That's all it does. It breaks it down to 1 of something. And scale factor is great to use here. How do we get to 1 from 3? Well, we divide by 3, which means we're going to divide our numerator by 3 as well. 180 divided by 3 is going to be 60 minutes in 1 hour, which makes sense. There are 60 minutes in 1 hour. Okay. The shortcut, not having to write out this proportion with scale factor, is you're really just going to take your numerator divided by your denominator. 48 laps in 8 minutes. 48 divided by 8 equals 6 over 1, right? But 6 laps in 8 minutes. So unit rate, you're breaking down the given rate to have a denominator of 1. If your rate involves a fraction, 19 jelly beans and 1/4 of a cup, you're still looking for 19 jelly beans in 1/4 of a cup. You want to know how many jelly beans in 1 cup. How do you get from a 1/4 to a whole? How many fourths go in a whole? There's your hint. Okay. Next objective. Call me Bon Jovi because we're about halfway there. Using a proportion, using equivalency and cross products. We've talked about cross products a lot. That's not an accident. Pre-algebra was big on ratios, rates, and proportions, kind of understanding what those things are and how to use them. So cross products or scale factor, we've talked about both of those so far. Those can be used here. If you've got to set up your own proportion, let's talk about number 4 here. You can run 18 laps in 16 minutes. How long will it take you to run 45 laps? When setting up your own proportion, the most important thing is to make sure your units line up. And what I mean by that is if you're going to write 18 laps in 16 minutes, you're going to set that equal to 45 laps. Whoops, I already put my line there. 45 laps in how many minutes, right? Notice that my laps is across from my laps and my minutes across from my minutes. Okay, that's how you want to set these proportions up. So ultimately, kind of get rid of the words here, make it a little bit simpler to calculate. 18 over 16 equals 45 over m for minutes. and then cross products to solve this, right? 16 times 45, which is, do some quick maths here, 720. And we're going to divide that 720 by 18, and we get 40. So you would run 40, or it would take you 40 minutes to run 45 laps, right? So setting up proportions yourself, cross products. Next objective, more proportions, why not, okay? You can see how important these are. 18 gallons of gas costs $56.52. This was obviously written about 30 years ago, but that's all right. How much does 1 gallon of gas cost? So with this objective, you're kind of deciding, what method within proportions am I using here, right? If I want to know what 1 gallon is, isn't that unit rate? 56.52 for 18 gallons equals how much for 1 gallon? We've already talked about that, cross products or just the unit rate method will help here. And then once you know what 1 gallon of gas costs, you can apply it to how much 31 gallons of gas will cost. Okay? And then how many whole gallons of gas can you buy for 25 bucks? Right? Once you know what the price of 1 gallon is, and you have $25 to spend, this is kind of a budgeting tool, right? How many gallons of gas can I purchase for that price? Your car gets 28 miles to the gallon. How many miles can you drive on a 16-gallon tank? You want to take a 750-mile trip. How many whole gallons of gas do you need? And how much will you pay in gas to take a 750-mile trip? It's all kind of interconnected. Just with one piece of information that 18 gallons of gas costs $56.52, you can use that to find all sorts of information that can help you plan for a trip. It can help you budget. Just no information. All of that comes from this ability to set up and solve proportions and rates. You can also use proportions to find missing sides of similar figures. Okay, some geometry here. Finding the value of x and y in that first one. And like we talked about earlier, how important it is to make your units match up. Here, we want to make sure our corresponding sides align. And the word corresponding refers to the same location. Like if I want to solve for x, obviously x is going to be a part of my proportion here. What side on the other figure corresponds or is in the same location as x? Well, that would be 9, right? So my first proportion, or the first fraction of my proportion, might be x over 9. And then I need to compare it to something. I don't want to use the y here because I don't want to introduce a second variable into the same proportion. So I'm not going to use the y or the 20 because they're corresponding sides there. But I'm going to use the 16 and the 12. And because I put my x on top of my first fraction, the 16, which is from the same shape, will need to go on the top of my second fraction, right? So x over 9 equals 16 over 12. What method do I use to solve this? That's right, cross products. 9 times 16 is 144 divided by 12, and x is going to equal 12. Okay, for the second one, find the value of y. Well, now I do want to use that y variable, right? And its corresponding side 20. And what's my other piece of this? Well, I could use the 12 and the 16. Now that I know what x is, I could even use the 9 and the 12 for x there. Obviously, these figures aren't quite drawn to scale, right? But 12 and 16, might as well use that again. Because y was the numerator of my first fraction, and 12 is from the same shape, I'm going to put the 12 as my numerator in the second fraction. So y over 20 equals 12 over 16. Cross products again, why not? 12 times 20 is 240. And 240 divided by 16, I get 15 as an answer. So y is going to be equal to 15. Okay? And that's kind of your process throughout here. All right. Next one. Maybe we're finally done with all this proportion talk. Oh, sure, probability. Here we go. I can determine the number of possible outcomes of an event. You may have learned the probability tree, kind of drawing out. It takes a lot of space, takes a lot of time. The counting principle is going to be the way that you want to go for this. And what the counting principle works is we kind of make an events outcomes table. Events and outcomes. If I'm flipping a coin 4 times, every time that I do something, every time that I'm choosing something, every time there's an action, that's considered an event. So flipping a coin 4 times, I've got 4 events here. I've got flip number 1, flip number 2, flip number 3, and flip number 4. Okay? And I want to record the number of outcomes for each individual event. So for flip number 1, what can happen? I can get a heads or a tails. There are 2 outcomes there. In flip number 2 and flip number 2 only, what can happen? I can get a heads or a tails. So there are 2 outcomes there. In flip number 3, there are 2 outcomes, heads or tails. And in flip number 4, there are 2 outcomes, heads or tails. So the question is, how many total outcomes are there for flipping this coin 4 times? Well, what I do now is I multiply all these numbers in the bottom of my table, and 2 times 2 times 2 times 2 gives me 16 total outcomes. 16 total outcomes. Let's do another one. Let's do one that can be a little bit tricky. Let's do number 4 here. Randomly choosing 3 numbers between 1 and 10. Numbers may not repeat, which is actually a pretty important thing here. So first of all, in my event outcome table, how many events are there here? Well, I'm choosing 3 numbers. There are 3 events, right? Choice number 1, choice number 2. I never made that long enough. And choice number 3. Okay. Now, how many outcomes are there for choice number 1? Well, I'm picking the numbers 1 through 10, and so there are 10 outcomes because there are 10 numbers, 1 through 10. But here's the thing: numbers cannot repeat. So whatever number I picked the first time, I can't pick that same number again, which is going to change how many outcomes there are for my second choice. Instead of 10, there are now only 9. And because whatever number I picked the second time also cannot be picked again, for my third choice, I have now lost another possible outcome, and there are only 8 numbers left to choose from. Okay? If numbers could repeat, it'd just be 10s all the way across the board. But because they cannot repeat, it's going to be 10, then 9, then 8. And again, to find the total number of outcomes for picking 3 numbers 1 through 10, when they cannot repeat, I'm going to multiply 10 times 9 times 8, and I get 720 total outcomes. It's a lot of outcomes. Okay? But that would be the counting principle, which leads us into calculating the probability of a compound event. So 2 things going on here, right? First of all, we have to know what probability is, just in general, right? And the second thing, compound. And let's start with just the probability piece. The formula for probability is, I'll kind of put it over here on the side, successful outcomes divided by possible outcomes. So this would definitely be something to where if you weren't sure about this, put it on the help sheet for the entrance exam. But successful outcomes divided by possible outcomes. And that for compound probability, just like a compound word, a compound word takes 2 individual words and puts them together. Like backpack or box cart or dinosaur. Maybe not that one. But for compound probability, we're taking 2 individual probabilities and combining them. Okay? So what is the probability of you choosing a vowel? You're going to start with that. Find each individual probability first. So what's the situation here? I've got 26 letters of the alphabet along with the numbers 1 through 10. So 36 total outcomes are in a hat. How many vowels are there? Well, there are 5. We're not including Y. Don't give me all that sometimes Y thing. A, E, I, O, U. Okay? So 5 vowels. Those are my successful outcomes out of 36 possible outcomes. Right? Now I put that choice back, whatever it is, I put it back. And now my second probability is choosing a consonant. Well, how many consonants are there? Well, if there are 5 vowels out of 26 total letters, that means there are 21 consonants. So 21 out of 36 total items. 21 successful, 21 consonants out of 36 possible, 36 total. So now that I've got my 2 individual probabilities to find the compound probability, the probability of both of these things happening, I'm going to multiply them together. The common mistake here is to add them. I'm going to be multiplying them. So 5 times 21 is 105. 36 times 36 is 1,296. So I have 105 out of 1,296 chance of pulling a vowel, putting it back, and then pulling a consonant. Now it does say to write my answer as a percentage. So to do that, remember that a fraction is just a vertical way to write division. I'm going to take 105 divided by 1296. I get a nice long decimal. I'll write the whole thing here just because. 0.0810185. Okay. 81, yeah, okay. to get the percentage, remember I'm going to move this decimal over to the right 2 spots, and so it would be an 8% chance of this event occurring. Okay, so that's compound probability. You are taking each individual probability and then multiplying them together and then converting that fraction to a percentage. Next up, 51, slope. We've reached the graphing portion here. So it says I can find the slope of a line given 2 ordered pairs. Remember, the formula is, well, here, let's start with this. So if you're given 2 ordered pairs, each ordered pair is an XY form. But because there are 2 ordered pairs, we're going to think about this as a first ordered pair, or X1, Y1, and a second ordered pair, X2, Y2, right? Notice how they're not like powers, they're not raised, it's not X squared, right? It's the first X and second X, first Y, second Y. And the formula is you take the second Y, subtract the first one, divided by the second X, and subtract the first one. You know, a common phrase for slope is rise over run. The rise represents the vertical change. The run represents the horizontal change. Okay, and how you find that is by subtracting the 2 y's and subtracting the 2 x's. So let's get one that's got some negative signs here. Let's look at number 2 because you got to pay attention to those signs carefully. Labeling your x1, y1, your x2, y2 could be helpful. So first y, or first x, first y, second x, second y. And then putting them into the formula, y2 minus y1 over x2. And here's where you got to be careful. Minus x1, there's a minus sign in the formula. My x1 value is negative. I need to include them both. Right? So this goes back all the way to the very first objective that we have in this packet. Wait, no. Second objective, third objective. Anyway, way back when you've got that minus a negative number, remember that actually means that you're adding. So negative 16 minus 12 means I'm starting at negative 16, and I'm subtracting 12. I'm going to the left 12. That's going to bring me to negative 28. In my denominator, I'm starting at 7. I'm subtracting negative 5, which actually means I'm adding 5, and that's going to bring me to positive 12. Okay? So make sure you're checking that addition and that subtraction rules there, because especially with this formula, it can be a little bit tricky. Since slope is a fraction, I do need to simplify this. So 28/12 I can divide each by 4, and I get -7/3 as a final answer. 28 divided by 4 is 7, 12 divided by 4 is 3. Couple common mistakes that oftentimes happen here. We already talked about that, the addition and some subtraction rules, following those. But also make sure you're putting your y values in your numerator and your x values in your denominator. Okay? But there's that formula, and there's an example done for you. Next one, graphing an equation in slope-intercept form. Slope-intercept form, if you recall, is y equals mx plus b, where the values that we really care most about are the m, your slope, and the b, that's a bad arrow there, but the b, the y-intercept. Okay, and so when you're given an equation to graph it, you want to begin by plotting the y-intercept point. And y equals 2/3 x plus 1. That b value, that y-intercept point, is 0, +1. So we're going to plot that point, 1 on the y-axis. And then we use that slope, that m variable, 2/3, and slope being rise over run, meaning from that y-intercept, from the first point that we plotted, I'm going to rise 2, go up 2, and run 3 over 3. There's my second point, right? Up 2 over 3. Okay? If my slope is negative, such as y equals -5/2 x plus 4, here's my y-intercept, +4. So I'm going to plot that point. And then my m value, my slope value, -5/2, I'm going to be going down the y-axis 5, but I'm still going to be going to the right 2. Okay? Kind of always remember your horizontal movement is always to the right. If the slope is negative, it means you're going down and right. If it's positive, you're going up and to the right. So then my line would look like that. Right? A couple other things to keep in mind. Y equals -x minus 2. Sometimes folks get tripped up as far as what the slope is here. When you've got a variable without a number before it, it means there's a 1 there. We don't write it, but it's implied. So this equation will be the same as y equals -1x minus 2. And how do you deal with the slope of -1? Well, remember that any whole number or any integer can be written as a fraction by putting it over 1. So this would be like -1 over 1. So down 1, right 1, down 1, right 1, down 1, right 1. That would be the slope. Okay? This one here, y equals 3 over 1 x minus 4, up 3 over 1, up 3 over 1, up 3 over 1, rise over run. And then number 6, there's no b value. Does it not cross the y-axis? Well, no. What number can we add to an expression and not change the value? It's like saying +0. You know, we don't write it because adding a 0 doesn't do anything. Okay, but for our purposes, for the graphing, it means that the y-intercept here is going to be at the origin, at 0, 0. Right? And then from that point, we would apply the slope up 4 over 3 to get our next point. Okay? PO 55, writing the equation of a line in slope-intercept form from the graph of an equation. So in 54? Yeah, in 54, I gave you the equation, you gave me the graph. In 55, I'm giving you the graph, you give me the equation. So it's just like the opposite, okay? And again, all you are really looking for is what is the slope and what is the y-intercept. Y and x are going to stay y and x. You care about what is the m, what is the slope, and what is the b, what is the y-intercept, okay? So I look at this line, and I see it crosses the y-axis at +3. So I'm going to fill in my y-intercept spot, my b value, with a +3. And then what I want to look for here to find the slope is where does this line pass through another corner? So I kind of follow it down, looking for a corner. Ah, here's a corner. Excellent. And then my slope is going to be what's the rise, what's the run to get from my point on the left to my point on the right? Well, I go down 2 over 3. Down 2 over 3. My slope, right, which I put in for m, is negative 2/3. But I put my x, I put y equals in front, and my final answer, I can write that a little bit neater I think. Y equals negative 2/3 x plus 3. Okay, another example here. Next one. This time, my y-intercept is at negative 3. So from minus 3, where my y-intercept goes. And then follow it till it gets to another corner. Let's see, where's another corner? Oh, right there, right? What's the slope to get from my point on the left to the point on the right? Well, I'm going up 2 over 1. 2 over 1, which I can write as 2 over 1 if I want to. There's my equation there. Or what is 2 over 1? Well, that's just the same as 2. So I can also write y equals 2x minus 3. Either way is fine. Both would be considered correct. So you're identifying what's the y-intercept, what's the slope, and putting it together in slope-intercept form. 56, I can write the equation of a line in slope-intercept form given an equation in standard form. Here's the conversion step, okay? Notice, slope-intercept form, we've written it on the past couple pages here, but y equals mx plus b. Notice what's different about the equations that you've been given. X and y are on the same side. That's not slope-intercept form. Slope-intercept form is when y is by itself. So here, it's the same two steps every single time. I want to move my x term over to the other side and then divide by my coefficient to y. So I'm going to take this 6x, I'm going to move it over here to the right side. And if you remember, what happens when you take a term and move it to the other side of an equation, the sign's going to change. Mathematically, what I'm doing here is I'm subtracting 6x from both sides. So 2y is by itself. And I can't combine 14 and negative 6x because the 14 doesn't have an x. They're not like terms. And the way that slope-intercept form is written, my x term comes before the constant. So I'm going to put a negative 6x. Again, notice the sign change here. It was positive 6x. Now it's negative because I moved it to the other side of the equal sign. And then positive 14. My second step to get y by itself is I'm going to be dividing everything by 2. That cancels the 2's out. Negative 6 divided by 2 is negative 3. And 14 divided by 2 is positive 7. So y equals negative 3x plus 7. Okay? There will be times when that x division doesn't work out evenly, like in the third one. I'll kind of write it up a little bit higher here. 7x minus 3y equals 30. Again, the two steps are the same. I'm going to move my x term over. It's positive on the left side. So when I move it to the right side, it's going to be a negative 7x plus 30. Again, all I did was subtract 7x from both sides here. And now, when I divide by a negative 3, notice that my sign followed this y term down. Okay, don't lose that sign there. If it's subtraction, it follows that term down. So I'm going to divide by negative 3. And I know what it's, negative 7 divided by negative 3, that doesn't work out evenly. But remember, this is a slope. That's okay. A slope is a fraction. So all I want to do is simplify this fraction. Don't write it as a mixed number. Don't write it as a decimal. Simplify the fraction. Negative 7 divided by negative 3. The negative signs will cancel out, but I can't do anything with the 7 and 3, so I just leave it as 7/3. And that's just fine. That's just fine. And then 30 divided by negative 3 is a negative 10. So my equation would be y equals positive 7/3 x minus 10. Okay, same two steps every time. Move the x term over, divide by the coefficient to y. Just pay attention to signs. We got to be getting close to the end now, right? Here we go. PO60. I can simplify algebraic expressions. So simplifying, that's the one where it involves combining like terms, the distributive property, or a combination of those two things. Okay? So the first one is an example of combining like terms. I've got 12 n's, I subtract 6 n's, I add 3 n's. You know, I have 12 tacos, I eat 6 tacos, I buy 3 more tacos. How many tacos do I have in all? Okay. It kind of relates it to fractions too. You have 12, well, I better not, I don't want to take it too far down the rabbit hole. But essentially, you know, they're all like terms because they all have an n. And whatever n is, I have 12 of them. I lose 6, I gain 3. Total, I have 9 n's, right? 12 minus 6 plus 3. The n doesn't change, just how many I have. My coefficient does. All right. For the distributive property, you know that you'll be using it whenever you see parentheses, which I do here. And what it means, I'm going to distribute this 8 into both terms inside of the parentheses. And I do that by multiplying. So 8 times 7n is a 56n. 8 times 4 is a 32 when I stop there. I don't want to add 56 and 32 because they're not like terms, right? The 56 has an n, the 32 doesn't, okay? But I've now rid myself of the parentheses, and that is the expression that I have. Further on down the page, we start to combine them a little bit, you know, like 19 plus 3 times 2n minus 4. You've got to follow the order of operations here. You would not add 19 and 3 first. You would distribute first because the distribution involves multiplying, and multiplication comes before addition in the order of operations. So you distribute first and then combine any like terms that you have. And that is a precursor for solving multi-step equations, right? These two objectives look exactly the same, only now there's an equal sign. So for the first one, 7n plus 4n minus 5 equals negative 38. I recognize that I've got to combine like terms here. 7n plus 4n, how many n's do I have total? I have 11 of them, 11 n's. And then I subtract 5 to get negative 38. I combine like terms to give me a two-step equation, because a two-step equation, it's basically the same steps all the time, every time, right? Start with any addition or subtraction, and then move on to any multiplication or division, use opposite operations. So 11n minus 5 equals negative 38. I'm going to start by adding 5 to both sides. That gives me, I'm going to do it over here so I don't run out of room. 11n equals negative 33. Negative 38 plus 5, negative 33. Divide both sides by 11, and n equals negative 3. I can check that very easily, go back to my original equation. 7 times negative 3 plus 4 times negative 3 minus 5. Well, this is negative 21. This is negative 12 minus 5. And negative 21 minus 12 minus 5 does equal negative 38. Okay, so you can check yourself very easily. When you distribute, kind of same thing. You know, you do this to give yourself a two-step equation. 5 times n is 5n. 5 times negative 7 is negative 35. And total that equals 60. There's my two-step. Boom. Add 35, divide by 5, donezo. Okay. Further on down the page, you do combine a little bit, but kind of the same thing as before, just follow those order of operations, you know. And number 6 here, remember that you are going to distribute a negative 2. That subtraction sign belongs to the 2, right? So our 9n just drops down. Negative 2 times 3n is a negative 6n. Negative 2 times positive 4 is a negative 8. And that equals 40. Now you've got some like terms to combine there, and that's going to give you a two-step equation. Okay, you have 9 n's, subtract 6 n's. How many n's you got? 3. 3n minus 8 equals 40. Two-step equation, add 8, divided by 3. You got it. Okay. Last objective. Woohoo! Here we go. 62. Variables on both sides. Kind of the ultimate equation solving exercise here. The first equation, 3n plus 6 equals 12n minus 48. Having n's on both sides of my equation is a problem because I want to get n by itself. Okay, So just like any time you move a term from one side of the equal sign to the other, you do it using opposite operations. This is different than combining like terms. I'm actually moving this 3n from the left side to the right. I'm doing it by subtracting 3n's, and that's going to leave me with 6, because these cancel out. 12n minus 3n is 9n minus 48, and there's my two-step equation to solve. Could I also move my 12n's over to the left? Yes. Do I do that using opposite operations? Yes. So if I wanted to do that, I'm going to be subtracting 12n from both sides to move that over, and now my two-step equation is negative 9n plus 6 equals negative 48. Notice the only difference between these two equations is that if I move my variables to the right side, I've got a positive 9. If I move them to the left side, I've got a negative 9. Because math is amazing, if solving these, both will work out exactly the same. In this one, I'd add 48 to both sides, giving me 54 equals 9n. Divide both sides by 9, I get 6 as a value for n. In this case, I'd subtract 6 from both sides. Negative 9n equals negative 54. Divide both sides by negative 9. And a negative 54 divided by negative 9 gives me a positive 6. Same answer, right? So it doesn't matter which side you move your variables to, as long as you do it and you use opposite operations when you do. Okay? One thing to keep in mind here in number 3, negative 5n plus 6 equals n plus 18. This is a 1n. So if you're going to add 5n to both sides, it's going to be 1n plus 5n, 6n. Or if you want to move your variables over to the left by subtracting an n, negative 5n minus 1n is going to be negative 6n over here. So just remember that if a variable does not have a number written in front of it, it's understood to be a 1. Okay? And that pretty much wraps up the entrance exam review packet. If you have any questions, please don't hesitate to contact me. If you need to do some extra research on how to do something, Khan Academy, great resource. The Google, great resource. YouTube, the full lesson for any of these objectives should be up on my channel. Just search for it by objective number, and the answers to this will be sent out or posted in the bulletin board in Blackbaud on August 29th. So hope you're having a great summer. I look forward to seeing you at open house or the first day of school or the new family barbecue or whenever our paths cross. But until then, have fun, math well. Bye.